now, let's talk about the effect of these lone pair of electrons on geometry. Okay? Let's take a couple of examples. Okay, I'm going to take off the lone pair of electrons of this model. Okay? And I'm going to make this tetrahedral. Okay? Okay, now that's a tetrahedron. Tough to make, you know what I mean? It's like a Rubik's Cube. Once you disturb one, it screws up everything else, you know? It's like you almost need a computer to make this perfect. Very difficult to make, the tetrahedron. Everything has to be 109.5, right? Yes, you got it? Tetrahedron, 109.5. Okay? Yes? All right. Now, if I take that off and I put on a lone pair, are these bonds now going to be 109.5 still? And if not, why?
Because the lone pair will push the bond away.
Well, that's right. You have, you know, if you have this stick here, you're taking some of those electrons and you're spreading them out, aren't you?
Yes.
You're spreading them out away from this, aren't you? Yes, and they're all spread out. And they're not going to have as much of an effect, are they? A little bit. We're not talking massive. We're talking 1 or 2 degrees here. We're not talking giant changes in geometry, are we? So if I take that away, then these electrons simply, they have no place to go. So they're going to fall right down to the atom, essentially, right? And then they're going to have more of an influence over these. So these are going to be forced a little bit more out of the plane, right? They're not in the plane now, but they're going to be even less in the plane. So what's going to happen if I take these and I go like this? What's happening to the angle between them? It's becoming less and less, right? Well, yeah. So if I go like this, aren't I decreasing that angle? So it's going to go from 109. It's going to go from 109. If I bring these together, right? This will go from 109 here to 107 here. We're just talking a couple of degrees. We're not talking a lot. First of all, it's approximate. Second of all, it depends on physical conditions. There's a lot of things that go on here. But the point is this, that it's not going to be 109.5 anymore. It's going to be something different. If this were perfect, that would be 109.5. Yes, if it were perfect. So then if I took off another one and created something like water, where you have 2, and you have a bent molecule with 2 unbonded pairs at 90-degree angles. That's my 2 unbonded pairs. See the pink? So what's this angle? Remember, this is related to the tetrahedron. They're going to be pushed together even more. Not much, but now all of a sudden, .105 maybe, ish. Yes? And you can literally do that with everything. But going from I mean, this is a perfect example of those non-bonded pair of electrons. If I have one here and non-bonded pair here, top and bottom, it's forcing these 4 in the same plane, 90 degrees apart. Yes? If I got rid of these non-bonded pairs, then I would form a tetrahedron. So the bonded pairs actually have a little less effect on the geometry than the non-bonded pairs do. Correct?
Yes.
End of part 2. Clear?